Hello everybody, welcome to another stream. How we doing? So last stream we was doing we was adding more to this plan, right? We sort of want to plan out how we're going to achieve this whole list here. So we've got this aim of building a stress test scene with a bunch of models, and so we can test performance and test these features that we're going to be adding. We'll test like features like lighting and stuff on this big test scene. So so to build this test scene, we kind of need to have features such as an LOD system and clusters. Let's see if the game still runs. There we go. So we also want to have, like, the whole world is made out of spheres, and we kind of want to have a variable sphere size. So we need to build a system that accounts for that. And we probably need some form of occlusion buffer, that v2, so second attempt at that. We also want to support animated instances, basically, and probably have some editor which allows us to construct models and things like this. So this is what we're going to be building. But I was tackling these one by one, and then it became apparent that they're kind of very intermixed. So I need so rather than doing one at a time and stop and pause and think, and put in a bunch of temporary code and all this, it became apparent that it was better to come up with a overall plan and just head straight towards that direction, basically. So off stream I did start this. Last stream we went over it and extended on it. So this stream, so there was still stuff left to do in the plan. So I'm just going to go over so basically I've completed the plan off stream. I'm just going to go over the changes that I've made, and then we'll get started on executing the plan, basically. So what changes did I make? So luckily it's all in Git, so Git can tell us. So I've sorted out how the allocation strategy was going to work for all of these guys. I think we can go over that in a bit. Oh, I thought it wasn't loading then, but you have to go down like this. I've basically added a quaternion into the code base because we're going to need one. I could have programmed this on stream, but I just thought it'd be easy just for me just to throw this in, basically. I'll briefly touch over what the quaternion looks like. So I did base this one off of linmath.h, but there was some parts of it where I was like, this is a bit sketchy, so I decided to based it off of this one, but then I decided to essentially complete it. I think it was getting a quaternion from a rotation matrix. I decided to do that manually. But yeah, so I've got it in the code base here. So we've got obviously identity. You can make a quaternion like so. You can get rotation from a let's get Milton out. So given a vector for an axis to rotate around and the rotation, you can make a quaternion. A way to normalize a quaternion, right? Same as a vector form. Get the cotangent, I think. So what's it called? What's this called again? I forgot how you pronounce this thing. Quaternion. Oh, conjugate. So this basically inverts the quaternion. It's like an inverse. Yeah. to get you the inverse rotation. I think that's what it does. But you need to use that. Multiply two quaternions together. Multiply a vector. So basically rotate a vector using the quaternion. I wrote one called look at. I ended up using this to make the to get a quaternion from a matrix. We'll see how well this one works. I basically coded this one. Yeah, this one myself basically, but see how it goes. So given a forward vector, yeah, so conjugate. Hey there, Osmosko, good to see you. Wait, conjugate. That's the word, conjugate. There we go. That's the way to say it. So given a sort of a forward vector and an up vector, so your forward could be that way, and your up could be up here, and basically produce a rotation to get you there, basically. Wait a minute. Given a forward, is you cross and get the right. Yeah, and how do you go from, given this vector, how do you sort of rotate? To get to this forward or something like that. Yeah, maybe that won't work. We'll see how it goes when I need to use it. This might need to be corrected a bit. But yeah, so I've got this sort of transform 3 from quaternion, and then I've got quaternion from transform 3. So that's the only programming I've done off stream, is just building this quaternion thing, which is untested. But we're going to be needing this in future streams, so I thought I'd just get the basis in for it. Yeah, the angle between the vectors, yeah. Yeah, let's see how it goes. Yeah, that probably is going to have to be fixed. I can feel it already. But that's cool. Yeah, dot product of equals cosine theta. Yeah, that's it. Yeah. Pretty awesome. That's a good feature. What else did I change? So I did the quaternion. Right, so I've designed the shaders basically on how I want this, like, all the shaders to work. I've not implemented them though. So I've got a bunch of comments which will go over those. I've edited the data structures a bit. So the edit's got a couple of extra. Well, I've packed it down to 16 bytes basically, which we'll go over. Right, let's just go over the let's go over the data structures first, probably. So I've changed this edit thing. It now fits into 16 bytes. Got a little stack assert for that, which is awesome. Basically, I've just packed it down. I've added these two things. So what this is going to allow us to do is when we're sort of painting down spheres, we could basically, if we're in add mode, we can have this. We have two different ways of saying how you want to replace the current stuff down. So you have a brush, and your brush will be at a certain LOD, like level of detail. So you could be on the lowest level of detail, the highest level of detail, and when you sort of paint down, you can decide if you want to replace the stuff which is higher level of detail than you, or lower level of detail than you, and you can switch on these options to say basically if you want to not delete the stuff that you want to that you're painting over, right? You might want to paint a higher level of detail around the lower level of detail stuff. So these options basically help achieve that, and we can, yeah, which would be pretty cool. So that's all I've basically added there. I've changed this volume that gets serialized out to disk, or that will get serialized out to disk. It's going to keep track of the total number of nodes and spheres and BVH nodes when you save it out. And the reason why we're going to do this is so when we load the model back up, we can pre-allocate the perfect amount. So when we reconstruct it from this sort of compressed format, which is just a history of edits, we can pre-allocate all the stuff that it can fill up, hopefully. Yeah, we'll see how that goes. That's the idea. Yeah, and then I've changed out the binned sphere to be an ellipsoid, which should hopefully allow us to do some more artistic things, hopefully. Because when you sort of take something from local space or take it from local space all the way to view space or whatever, or world space, there'll be non-uniform scaling going on, and maybe skewing, depends, right? Or non-uniform scaling mainly. So that produces ellipsoids. So maybe we can play into that. Maybe that can be a great artistic feature where we basically construct ellipsoids. Cool. Yeah, so that's the data structures that changed. So I can just briefly go over the shaders. So yeah, after I've done this recap, we're going to get started on this shader here, which is going to allow us to construct a cluster tree. So effectively, the what we have is our a tree of 2 by 2 by 2. Okay, we have our spheres, which are going to cluster of 2 by 2 by 2. It's in the plan, right? So our clusters, which are 2 by 2 by 2, and we have a tree of these clusters. So the root level is going to have a 2 by 2 by 2 of spheres, and then inside those spheres, you're going to have another cluster, and they'll go all the way down to the highest level of detail. So you can imagine you've got your 2 by 2 by 2, and this is like maybe this is like 1.6 mil. And then, but when you zoom out, you can't see this 1.6 mil spheres. So you need to produce a lower level of detail. And this is where you make that cluster will get replaced with a single sphere from the parent cluster, which could possibly have more spheres, right? So this one's so yeah, this is a so this parent cluster currently has 2 spheres, and each of these spheres have a children cluster with 4 spheres in them, right? That's a 2D example, so it's one less dimension. So basically what we need to do is we need to decompress. When you probably enter a scene, or when you see, or when something comes near the camera or something, we need to have a shader that turns a list of, we essentially need to take a list of edits. So a person sort of constructing this model that they've made. So we need to decompress that from a list of edits into this cluster tree. And the way this shader is going to work is we'll dispatch 10 versions of these, one for each level of detail. So we'll start at the top of the tree on the lowest level of detail, run over all the edits for that, and then we'll go down to the next higher level of detail, right? And then we'll go over all the edits for that. And there'll be synchronization between each of them at a time. So essentially, we should be able to build the whole tree this way, by just going over each level of detail one at a time. And we only have to do this once when the thing becomes on screen. And if the thing goes off screen, it potentially the memory possibly gets recycled when another volume comes on screen and we need to make space for it, basically. So this is something we'll start building today, and we'll probably just do a simple version of it and not support everything. After that, I think we want to sort of like reshuffle the leaf nodes, because so essentially we want to put the leaf nodes in a contiguous piece of memory, because when we try and render this thing, our shader, like we want to bin these clusters or spheres into some view space acceleration structure. So the best way to do that is to get access to the leaf nodes and just go from there and see, hey, is this leaf node visible and is it big enough to render, right? And if those things check out, we'll render it. So having them in a contiguous piece of memory will be great. So we need to reshuffle the leaves, and this again has to only be called once when you construct this tree. The tile and Froxel binning. This, I think I might have to change this a little bit. So we launched it over every leaf node from the cluster tree, traverse up the tree and stop when we find a cluster that's X many pixels big. Now I think we might want to do the occlusion buffer v2. I think I want to separate this. That's why I've just copied it. So I think I want to do a step where we do the occlusion first, build up a low resolution occlusion buffer, so it just has a depth per pixel. We'll probably rasterize it with triangles. So this was all in a single thing, but I think we might need to break into two. Stop when we find a cluster that's X many pixels big. We kind of want to stop when we find the most parent cluster, the most lowest LOD cluster with no gaps. Between the spheres in view space, which I think we can work. And then we append this cluster to an array of clusters to an array of occluders or something like that. Launch over the occluders and build triangles for those guys. Leap over the triangles, rasterize them into the occlusion buffer at the lowest quality MIP possible. Yeah, because you want to avoid then you probably want to do that sort of propagate the MIP, the depth between the MIP levels. So you have to go the way up and down the MIP levels. Then the Froxel binning is just going to go over all the leaf nodes, traverse up the tree until we find a cluster 6 pixels big, append this to the array, render all clusters, test against the occlusion buffer if it's visible. If the test passed, then bin this in the tar/Froxel. Maybe, do we need to append it to another array? I think we could probably just do this, right? Just combine it all into a single shader. I don't see there's any benefit putting out an array and then rereading it from the array. I think you'll launch just as many threads doing it this way. So yeah, and then we have a BVH construction method as well, which I think, yeah, which we'll get to later. Okay. Oh, Russ must go. I was having to think actually. Where's your thing that you had? It wasn't yesterday. It was here. This guy. It's gonna show. Hey, the points aren't even showing anymore. Oh, there we go. Good. So, I remember when you plotted this out to show that you can do the to show that you can do you can move the axes in and sort of bunch the spheres up next to each other and hide the holes, or you can offset the sphere positions and cover the holes. I'm thinking that maybe this could still work. I'm not sure though. But maybe instead of doing it with the axis approach, maybe just offset the positions manually. And maybe as they paint down, it might not be so bad. But I don't know, it might not work out. Maybe as they paint down, they might draw a different type of, it won't be skewed like this, because they'll probably draw it straighter, although you get some sort of, I was thinking one time, it'd be something like this, right, where they sort of go, it might look something like this. Rather than looking slanted. Yeah, rather than looking slanted, I think it might look something like this, where it just goes in and out, basically. I don't know. Just thinking about it. Comes out, yeah. I think it's just the way, it's just because we've taken this shape and just modified the transform matrix, right? But I think as you place the spheres down in this sort of world where the grids are slightly offset every other position, maybe it could work. I don't know. I'll have to try it out. It might not be too hard to try out though. It's worth an attempt though, I reckon. Right, so I think we can get started on this plan. So, right. So we just want to start on the edits, basically. Wait, what shade are we starting on today? Constructing a tree. So we need everything GPU side. Okay, so this is the new sort of stuff. I'm not sure if I tried to get any of this stuff compiling yet. But we want to build... Right, let's just release it all. See what happens. Right, some of this stuff is kind of CPU only. So I should probably just say if def. Oh my days. So I think all I need is this edit sort of stuff, to be honest. And I could probably stick this out of... Data volume. Yeah, I don't need any of this just yet. Alright, so got this now. So we'll build up these edit things. Alright. So then I need this sort of GPU data, so all this material stuff, we've got material palette, volume instance, volume. Hey, not so red, how's it going? Not doing bad, not doing bad. Just been chilling, been off work, just been seeing family today, saw my parents. Helped them move some stuff into the attic. Let's sat and spoke to my dad for a bit, and then we came back. Yesterday, we went Christmas shopping. Got like probably about 65% of the gifts all in one go, which is pretty good. And yeah, just been exercising and rewatching Lost. So that's been my life so far. And also, yeah, I've been planning out how we're going to tackle this next big thing as well on the project. But yeah, how's things going with you? You nearly off for Christmas? Right, so luckily this is all compiling. We need a GPU buffer filled with volumes, and we need a buffer filled with edits as well. But yeah, right. So let's get those buffers in there. Right. See, hopefully we can just build this new system and then and keep the old one alive as well, and we'll just sort of make the switch at some point. So I reckon we'll just do if one, and this is where all the new stuff is going. New stuff. So we'll build a buffer. This is going to be the so volumes. These are all the loaded volumes go. So the volumes, how many volumes can I have loaded? You know, I guess we'll just say 1024 for now. That'd be a volume. Cool. So you have a volumes buffer. We need a volume edits buffer. It's the total number of volume edits. We might say like 65,000 of those for now. Probably do with more. 64k ought to be good enough. Goes a long way, 64k. Yes, we'll throw that into the... So we need those. And I think we can just get started with that. So volumes, volume edits. New stuff. I'm good, busy with work, but it ain't really that bad. I wish I had more free time to work on my own stuff though. Only have the weekend. Oh, fair play. Yeah. It's all the travel, isn't it? Yeah. Do you not get like Hmm. Are you driving to work? Did you have a car? Or can you not get like the train? And maybe take a laptop or something. And you can like sit on the train for a bit. But yeah, the train journey isn't that long, then maybe it's not worth it. No, people don't celebrate Christmas here, fair play. Yeah. Wait, what country are you in? Yeah, because the funny thing about Christmas, yeah, it's kind of funny. It's like a complete made-up holiday, basically now. Yeah, people go pure crazy over here and just put like, well, some people do. They'll put like tons of decorations all over their house and then lighten up the whole street, and it's like completely made-up holiday. But today, Morocco. Oh, okay. I didn't have a car. Fair play. That's good tea. Right, so instantiated the new stuffs. So we can upload the edits every time. Um, so you've got to have somehow mention like, so when you dispatch this, Oh no, this is gonna be easy. This is gonna be easy. Alright. So we need to do an upload on this guy. Oh, wrong place. Oh yeah, I was building all this model thing. Yeah, models don't exist anymore. They're called volumes. So, if we just fill a buffer of these lovely little edits, let's just say we're only doing like 3 right now. We just need to get the system working. Let's fill in all these fields manually, because that's what we like doing manually. All the way. How's the project going? Any progress? Yeah, it's been pretty good. We've got multiple model instances. Can I show that? Yeah, so we've got multiple model instances in. So we made a to-do list where it's like, this is what we want to achieve. And the first thing was multiple model instances. But then, as I started doing it, I was like stopping and pausing and thinking all of the time about overall design at a higher level. And what else was I thinking about? Yeah, so basically I made a, so these are the things I want, right? So multiple model instances, LOD system with clusters, a variable ball size, because the big balls aren't enough, you've got small balls as well. We want a second attempt at occlusion buffer, and hopefully that'll help us out. We want to support dynamic and animated instances of volumes, and be able to make an editor. For the ultimate goal to build and stress a stress test scene with a bunch of models so we can test performance and test graphical features like lighting and stuff in that test scene. Yeah, it's going to be, yeah. So basically, I've gone and designed the whole thing here where, what is a LOD, what is a cluster, what is a BVH, what is what materials look like, what is a volume, and essentially just deciding that if we're trying to work out that we can actually probably get something as small as 1.6 mils, but if you do that, your largest thing is going to be 1.6 meters of inside one volume that you're constructing. But you can scale both of those bounds up together, and have something as small as 16 centimeters, right? And go up to something as big as 160 meters. So that's pretty dope. So the aim is to make this work, and if we can, that would be pretty killer, because we can then give the controls to the person who makes the art, how loaded up they can make a level, basically, as opposed to it being a fixed thing within a hard-coded system. We can play around with it at the art level, I guess. And things can go as small as 1.6 mil, which means you can build fingers. 1 mil is tiny. Probably 2 mil. it'd probably be 2 mil to be fair, but yeah, about 1.6 mil. And we might be able to get it compressed down to a very small piece of memory as well, and have animated volumes that possibly, or they'll look very lifelike, because we'll be able to animate them with bones, and the holes won't matter so much because there'll be spheres on the inside of the volumes. So it should be pretty cool. Now I've just got to program it all, but it's all been planned out now, so it should be less thinking and more. They'll be thinking at the low level, but high level thinking is all planned out, hopefully. So that should be pretty cool. So we're just gonna probably build a very simple version of it first, and then we'll just bolt all the extra features on, basically. So we're gonna have these list of edit operations. This idea comes from Dreams, basically, which is on one of their sort of presentations, where if you have a 3D volume of if you have like a 3D volume which is like 1024 by 1024 by 1024 of spheres, you know, that's 1 billion spheres. That's 1 gig at minimum of space you need if you're to fill that space. But what Dreams does with the SDF technology, which is different from this, is they basically compress it down into a bunch of edits. So from the time when you constructed your thing, from the time that you started your thing with nothing to the time you've built it, they just record every action you've done, and they just replay that back when they want to load it back. So we're just gonna do something like that, because ideally, if we had thousands of operations, that's kilobytes of memory at least, instead of gigabytes of memory at least, right? And to save being gigabytes of memory in memory at runtime, we're going to be having a variable ball size. So on the insides, so around the edges you have the micro detail, but on the insides you have the bigger detail, when it's surrounded by a small detail, basically. So, Rosmusko. Did it test performance with a large amount of spheres? We've tested. We didn't do it with the new stuff, no. But from the stuff that we've done earlier, I know that I can get away with 64 tests against spheres per pixel. And we get around 1 millisecond. So as long as we have something like that, then that would be around 1 millisecond. But I think we can have up to about 4 milliseconds if we want to aim for 60 FPS when we just render geometry. But yeah, I think we can. I think I want to try and aim for 1 millisecond. But just so hopefully we can scale up to 4K from this hardware, basically. And also have I kind of have this weird low resolution that we're testing it in. Oh my days. Terrible technology. Look at this. This is actually causing my GPU to work. I can feel it. Yeah, I think I want to give my stuff that that slogan, terrible technology. Right, so what am I looking at, Rosmusko? This is a lot of balls. Have you got balls on the inside here which are bigger balls? Oh my days. That's a lot of points. $160,000 values. This is roughly what we had 160,000 on the screen, and it was about 1 milliseconds. It was about that number, surprisingly. Oh, a skewed grid. Oh, this is the skewed grid. Oh, of course now it's so obvious when I'm looking at it. Right. Oh, so it makes this sort of hexagon thing. Okay. Hmm. Not centered around that thing, so I can't figure out how I'm moving around it. But yeah, that'll be. Oh, skewed grid. Oh, I see. That's what I've done. Right. I see what I did now. Thank you. Appreciate it. Yeah. This looks doable, doesn't it? Something like this. That doesn't look half bad for a sphere, though. If they pass the test. Cool. Yeah, we could give this a go. Instead of having the bigger balls, because the best thing is you can see about this approach, you might be able to, you can probably see the individual balls, whereas if they're all squished up, it looks like all one squished surface, maybe. I don't know, I have to try it out. See which one actually looks better in the end. That's interesting. Have you got the code for that as well on your GitHub? Wait, you've got it, haven't you? Yeah, it's in the more code bit, isn't it? Excellent. No. This one, right? Data skewed. Oh, 7 minutes ago. Excellent. Uh-huh. Dead axis, okay. Go over all your... Right, within the sphere radius, right, then plot it in there. Skewed from straight, so it's a matrix, right? Nice. Yeah, just assign distance. Cool. Right, so that's with the skewed grid. Yeah. Okay, so yes, it's just the ship that was testing earlier was just plotted. Okay. Yeah, this maybe could work then. Awesome, I'll keep that noted, thank you. Right, so on like an edit operation, shape, let's do the ellipsoid. Um, um, rotation. We can just do 0. That'll be fine. Center position is fixed point 10.6. 10.6, right? It's 10 bits of precision in the integer part and 6 in the... Yeah. Alright, so that's the packing. So... So... Let's just do one edit for now. Let's do... How big of the volume do we want to do? So 1024 by 1024 by 1024. Let's just do... let's just do 64, it's always a good number. Shift left 6. Oh shoot. We want to do that for all of them. Right, so let's just single edit there. Just do a sphere basically. So we've uploaded that to the GPU. Now we need to actually get the shader going. Right, so this is the shader. That we're going to use to construct the tree. We're going to dispatch one of them for each LOD. So we need to build this data structure. These are our push constants, basically. Okay. With a hole in it. Ew. Oh, this is good. Yeah, you definitely get those patterns show up. Interesting. Yes. The Death Star. Yeah, I reckon this can work. Because if we're going for small balls, right, the imperfection of the like exactly where they go doesn't necessarily matter as much. Whereas if they were bigger balls, you kind of need to place them in exact places, right? But I think we're going to be able to manage small balls. Tiny ball. So that'd be cool. Nice. It's awesome. Thank you for that. So we need to say, hey, what volume are we modifying? Or are we setting up? What is the number of edits? And also, where does the edit start? So I think we could just roll with that. So data volume edit, I guess, equals. Okay, we obviously need the buffer. Read only buffer of volume edit. Then we need probably a read write buffer of volumes that we're ultimately going to contribute to. And we probably need a way to allocate our clusters and things like this. But we'll start writing out the shader and we'll see as we go. So BC. Oh, I press buttons. Edits. BC edits start index plus edit index. Bring out the edit. Boom. So do one LOD at a time. So ultimately we're trying to construct a cluster tree here. So we need to see where this edit sits in the so we need to unpack these fixed point values. And also they can't be U16 times 3 because you have to have 16-bit integer support on the GPU. So to avoid that, we'll just manually pack it. So we'll just be like pos dims 0, pos dims 1. Not my finest bit of work. But they're just packed into there. So basically, wait a minute. Sorry, I got bit fields. I can have my finest bit of work. 16 bits. For the X, Y, Z, right? So we want to have a way to sort of, we'll probably have a nice little macro where we'll just call it like pack fxp 10 6. So you pass in your value, that pack it down from a float into a, then you have the unpack. So the unpack is just going to be value shift right 6. So that's your integer part. Cast that into a float. Plus probably something similar, but with a but probably with like an and. The 6 bits, so it'd be 3f. And this is your like fractional part. So Just divide it by the max value. So 1 shift left 6. What is that number? 64 in it. Divide by 63. On F, and then away we go. So that should be how we unpack each of those guys. Then to pack it, it's just the other way around. So you want to basically extract out. Wait a minute. Yeah, that's fine. So you've got a floating point value. So we need to take the you probably just truncate. Do I do a trunk? Truncate. And then that's your, and that goes in your higher bits. Then you probably want to, yeah, that's fine. And then truncate, cast C 32, shift left 6. Then you want to OR that with so what we do here, so you want the sub, you know, you want the measurement value 123.66. So we've just done that 123 part with the truncate, so that made it 0, 0, cast an integer, shift left 6, put in the higher bits. But the low 6 bits need the fractional part. So what's the other one called? So there's trunk. So there's one which does a floor, and then it'll do a, no, maybe, it's fract, isn't it? That's it. Yes, this one should actually probably be floor. Yeah, floor, then this one should be fract. And fract basically uses the floor, so it should hopefully optimize that. The fract just as a floor, then a takeaway floor from V. Gives you the fractional part. So given the fractional part, so the precision we've got is 6 bits of precision. So the smallest unit is it? It's 1 divided by 64, right? So that's kind of the step size. So we probably just need to sort of, so you can like round it to the nearest multiple of that somehow. We have a function to round to the nearest multiple, but there must be a more elegant way to do it. Right, so this one doesn't need to do a shift left, by the way. It just needs to be ANDed with this to be safe. But that's not the answer. So you want to somehow encode that given the step size of this. You'd have your 0.66 or whatever. Then you want to... divide 0.66 by this number. I think. Good, right. Then that's 42. And that'll go... Right, so if we had 0.99, it'd be 63. Right, so it's 1 divided by 63. Just that number. So you want to do... So if you had 0.99 divided by that number... is this right? Because the only time it would be full on 63 is when it would be 1. Which is not... Yeah, so I think it's 1 divided by 64. Yeah, so you want to say... so you fract that, then you divide this number by 1 divided by 64. Now, there's probably a way to simplify that sort of thing about it. Yeah, the fact you didn't divide 1 divided by Anyway, that'll be optimized out into a constant. So maybe it's alright. This could probably be made into a multiplier though, couldn't it? So the fact if you did 1 divided by something like that. Let's make it into a multi. You do 1 divided by... Yeah, so you just times it by 64. That's all I needed to do the whole time. So we just times that fractional part by 64. That would be it. Okay. But I don't know if it's 64. Yeah, so it will never be 1. Yes, that makes that 64 then. Okay, so there's our float point FP16, although this should be F32 version, but one version which does the vectorized version of that, so we can basically just achieve, so packing it, you want to pack it into a yeah, you know, we probably don't care about that, to be honest. We maybe care about the unpack. Oh, you know what? Maybe it doesn't matter. Right, so we can now use this guy here. So we just want to basically unpack our center position. This is in volume space. So it's edit dot center position X. Still a thing, right? Good. So this would be unpack fxp 106 f32, and then we want to construct And then you'll do another unpack. So this one's going to be the half dims. Cool. So what else have we got to achieve this thing? So the rotation we can simply choose to not care about yet. We can still do rotation. But yeah, we can just add it in. Yeah, just add it in a bit. We can also choose to ignore the shape for now. We can just assume it's going to be a sphere. And just assume it's going to be adding. Oh no, we'll do the switch. Edit.op. Case. Volume. So there's an add and there's a remove. So do the classic wrap it in scopes. It's probably a little bit complex. Okay. So we need to like traverse down the tree and allocate any nodes. So there's a few things that we need to do. Is we need to have so this volume needs to have an array of nodes that we can bump allocate from. So we need to have a range of nodes that we can bump allocate from. These cluster nodes. But we're launching 4x4x4. At a time, so each thread has its own place within the volume, or its own coordinate within the volume. All new volume dims at LOD. Which would be a you only need 10 bits for that. So we could just pack it all in. It could be a ×3, but we don't get a lot of bits in here, or a lot of bytes in here. Yeah, it might be fine like that for now. But in future we can always pack that down. Just to make it easier. But yeah, to allocate these clusters, you need like a shared place. So the only place to do that is to store it in the volume itself. So the volume itself will need to have information passed up to it somehow. Like we need to be able to say like reset volume, and that's gonna just reset. So we, just set it up basically. So just be like a 1x1x1. Volume reset. So all this needs to do is effectively just do volumes index, and then we use our volume index that will pass in or something. And then we just basically go ham with all the values for the volume. So if we look at a volume, what sort of stuff we need to reset? Not one of these guys, one of these ones, the GPU ones. So we need to only overwrite ones that are necessary. So the edits start index. So yeah, you'd only reset it when you need. So I guess you can keep it around with garbage. better that way, I guess. So the number of edits, probably clear that out. This will get set after the tree construct. Wait a minute. The last thread, yeah, so this can be used as the counter. No. Yeah, so the start index will point to the range that's been allocated. And we just bump allocate it using this number. The only problem is reaching the end and overflowing. Oh, sorry, it's not the edits, is it? It's the cluster nodes. Right, so these will just be cleared. We could use them to bump allocate and assign them later. No, we'll just pass them up and assign them now. Because it might not be possible to set it in this sort of manner. Cluster tree root node index. Cluster tree leaf node start index. So these guys are not used when constructing, so this means we can use it to use these as the bump allocated stuff, right? So this one will be set to. So the root node will get allocated first. So this will just be where the cluster tree nodes start index, and then we'll use this to bump allocate. We can set this to like a terrible value. This can just be used. So cleared so we can bump allocate. Volume cluster nodes. And then the BVH tree one. That can just be cleared to like U32 max. And default palette, material palette, index, we'll probably not have anything set there. And then grid dimensions. This should probably be passed up in the yep. So we'll initialize it to something like that. And then from here we can bump allocate some clusters. Stuff like that. Right. Reset BC. So you need your volumes. They're basically probably just kind of write only, but write only volumes. You need a volume index. You need edit start and count, and need grid dimensions. Then you could probably work them out at each LOD as well. All right. I just need to go and get another drink, and then we'll carry on with this tree construct. BRB. Right, so welcome back, everybody. Oh, wrong one. Right, so I've got some more water now. So. Oh. So. Constructing a tree, so we need to have a way to allocate these nodes basically. So we need to walk the so we probably should allocate the root node. So you reset volume. Um So when you reset a volume, so we should probably only hmm. I'm trying to think of the case when a volume might have, like, a volume can be loaded at any level of detail. It might not have a lowest level of detail. Thinking about it. Um, Depending on the model. So I'm trying to think of these edge cases. Um, so when you allocate like you could always allocate a root node. Oh no, sorry, you'd always need a node even if it doesn't have a lowest level of detail. Yes. So we should probably make the root node always be allocated. Okay. So in this case, we'll set it to 1. Right, bump allocate the root. Now what's special about this root node? Where's the cluster? Wait, why didn't I set this to anything? Um, Volume cluster nodes. Yeah. Not sure I remember getting rid of that. Alright. This is going to be good. So, where's that first cluster? Can I have a look at that one? Cluster node. So the cluster node has basically positional information. Parent node index, sphere range. Yeah, so we get to set this initial one up. So let's get this in the so let's get these boys. So this would be a BC volume cluster nodes, BC volume cluster nodes start index. This is the root node. So we'll set up the root node. Oh ho ho, what's this? You got LODs as well? Oh, that's cool, you join the box now. That's even better. So we can see, debug that when it loads in. Ah, interesting. Right, so you can still draw it in there, but the bounds become a bit skewed maybe. Hmm, questionable. Drag the slider. Oh, ooh. Oh, this is how I want to do the loading. Yeah, this is how I want to do it. This is good. Yeah, yeah, yeah. It's kind of only if it has them. You got this. This is gonna be lit. I love it. You can just demo it like quicker. than I can. This is going to be great. Hey there, Kid Payne. We'll be balling. This is going to be so hype. Yeah, I'm not sure how the skewed volume will be like though when we... You know, it might be really weird for an artist when they're drawing near the edges of this thing, right? Although they won't be drawing near the edge of it. Because the volley, like, we can always move it inside the volume. Yes, it means as they'll have more space. I don't know. Yeah, we can always move the thing within the volume, basically. I don't know. No need to follow the script. Oh, the... Ah. Alright. Yeah, it feels a lot more organic if it... The way it sort of... It might feel a little bit more organic the way it did it this way. Which is another reason for it. Feels less gridded. You know. Feels more, yeah. It's pretty cool. So the lowest LOD, so you've got grid bounds. Like you kind of don't know where this is yet. And until this LOD, yeah, what am I thinking about? What is this, why do we need a position in here? Basically, this is just a position. So you got a cluster node, which is 2 by 2 by 2 spheres. So this should just be, at this level of detail, it is simply this position. I think that makes sense. So it's at this level of, at this LOD, what is the position? And then the size is obviously just 2. Right. So I think that's the way we'll roll with that one. Because you can always like, if you want to bring it up to another level of detail, you just shift it. You just multiply it. Shift it by 1, right? Sphere range. U32 max because there is no sphere range. Children. Yeah, so these children... See, that's another thing about the children. You have 8 individual indices. You can stick all the indices next to each other in another array somewhere, or they can become part of the cluster node structure itself. Not all the leaf nodes will not have children, so by doing this, you would save out on all leaf nodes, which will probably have the majority of things. The majority of the nodes will be leaf nodes. So you would save out on 8 times 4, right, which is 32 bytes per leaf node, which could actually add up quite a bit. So we should probably also have these. but then you'd add a layer in direction, right? You'd be like, oh, what's my you'd have to go and get the indices from another um unless your child nodes all sit next to each other in memory, in which you only need one. But then as soon as you have, so this allows for empty nodes. This means as soon as I have one, I've allocated 8 of these guys. That means your nodes should just be allocated in groups of 8. If you did it this way. And you probably want a bunch of bits, like 8 bits or something like that, to say which. If you did it this way, you want 8 bits to say, oh, which ones the nodes are actually populated. But then this means you're allocating 8. Yeah, I'm not sure which way is better. This way means you can have holes. Yeah, I think we'll just difficult. Because you could have them in a separate array, but then that's a lot in direction. We'll just keep it like this for now. I don't know if this is a good idea. And we'll need a way to index into this as well. Alright. So that's when you reset volume, something like that will happen. So you have a root node basically. So this is where the fun begins. Anakin Skywalker. So when we construct the tree, we go over all the edits. Each thread gets a coordinate within the 3D volume, and each thread goes over all the edits, right? So you need to traverse down the tree. So given this shape, we're just going to assume it's we're just going to assume it is a ellipsoid for now, or a sphere for now. We need to traverse down the tree from the root every time, every edit, and we need to find wait a minute, I haven't got which LOD we're targeting in the this is a bugger. I need more bits. Where are my bits? I need 4 bits. And I haven't got enough bits. Like, because with 4 bits, we need to know you're painting down at a certain LOD. Is that right? Am I right by saying that? Because you have your dimensions right of your Do we need 10 on these guys? You certainly don't need 10 on these ones. 10 will get us 1024. You probably need, like, you need half. So we can get 3 extra bits here. But part of a different word, that's the problem. Like, it's a different word, there's unused there. We need to traverse and find the... Oh, and LOD. Right, let's remove this restriction for now. We can always do the rotational packing thing. So we'll call this like target LOD. We need 4 bits for that. We only need to go up to, we need 0 to 9 inclusively, which kind of sucks. So we need to traverse down the tree until we hit the target LOD that we're painting at. And if our thread simply doesn't have a coordinate. Oh, wait a minute. So we traverse down the tree. As we traverse down the tree, if the tree doesn't contain any clusters for what we're painting down, we need to allocate some clusters and set those guys up, but they don't have any spheres in them yet, something like that. Yeah. So we traverse down the tree. So for an add and remove, probably the same. You just need to find an area. Like you're targeting a LOD. Ugh. Might be let's just assume we're doing add for now. We'll see how it works. So do a while loop. We'll probably have like a max iterations. So probably just do a for loop of let's just do 64 for now. Probably only need less. Just trying to be a little bit safe when I'm programming on the GPU because it can crash and burn my machine. So we're just looping down right. So we're getting on node, cluster node index 0. Well, technically we should work. Okay. Yeah, if we work with relative indices, then it means we can always migrate. We can always defragment the buffer. Oh, that'd be pretty cool. We can defrag the cluster nodes buffer by just literally copying the data around and it'll be fine. And then patching it for each volume. That can work. So we go into here, we go, okay. We probably want to fetch the volume cluster node. So, you have to look like you're pulling the whole thing out, but the compilers will use pointers behind the scenes and only load the data you need. But hey, GPU programming. Cluster node indices. Okay. And we should probably, for safety, Okay, so we've got to go off some. Where's our volume? We need to pull the volume out that we're editing. Volume. Volumes. Volume index. Volume dot. Cluster root node index plus this. Now we should probably, we could easily go out of bounds here and that'll crash from a GPU. So what's probably best is we have some capacity here on this buffer. So if we min it and get the wrong one, is that just as problematic? Because we will start editing that one. Yeah, I don't think there's any good way. Let's just index out of bounds. Well, no, we can clamp it within inside the range of we can clamp it within the range of the um, hmm. Okay, so we should be able to we should um last cluster node index volume dot cluster tree root node plus the volume count take 1. Now that could, we got to always ensure that we at least have something, I guess. Be able to min it with that. So min U32, and that's a nice thing to stop it going crazy. Okay. So now we've got this node, and this will start as the root node. Now we need to do a check. The first check would be, so we probably want to have a thing known as LOD. So what is the current level of detail? Currently on the lowest level of detail, LOD 0. So we'll traverse down the tree. So we're doing a 4x4x4. Right, we're only constructing for this LOD. Yeah, we're only constructing for this LOD. So we could probably traverse down. Um, yes, you need to traverse down the tree, and if you're adding, as you're traversing down the tree, there's a couple of settings on this edit, basically. Inclusive lower and inclusive higher. So inclusive lower, if that is set, will overwrite any lower LOD. It will overwrite any lower LOD's data. Whereas if it's 0, it's going to preserve it, so it won't replace it. So as you're going down the tree, if you go through a lower LOD and the lower inclusive is set, you'll basically if edit dot. So first of all, we need to sort of check. Hey, is this edit inside? Is this thread? Does this thread correspond to this LOD? So you'd only want to sort of make changes to this one if this is like a leaf node as well. Only if it's a leaf node. Because if it's not a leaf node, then the lower levels of details are just a automatically generated thing, basically. So you want to know, is this a leaf? So that's another thing we need to be able to keep track of is leaf. It would be amazing if we could make this easier, because having 8 individual indices and checking against all of those to know if we're a leaf is silly. Having them all come after one another is kind of great in that regard, because you can just have a bit set. Well, you can still have a bit set of knowing which ones are set. So you probably have this thing called like a children bit set. So they're all off. To start off with, obviously. So you want to know, is this thing a leaf node? Boolean is leaf. So this would just be children bit set equals 0. So if this is a leaf, and I'm not sure, we might need more stuff, so we'll do this sort of branch here. And we have a inclusive lower. We want to kind of destroy this node. So we want to say, hey, all those spheres that are here. Wait, not all the spheres that are here. Wait, it is a leaf node. Yeah. There's a 2 by 2 by 2 set of spheres. Like you might paint over some of these, but not all of these 2 by 2 by 2 of spheres. But you're only going to be tunneling down. Wait, so what lot are we targeting? If LOD is not equal to edit.target LOD. Then you kind of just want to destroy the sphere for yeah, you want to destroy the what's the thing inclusive? So this will overwrite any low level of detail if on, and then replace it with the higher level of detail stuff. 0 will simply preserve it and not write any high level detail of stuff in that area. So it'll kind of stop there and terminate the thread, which is kind of interesting. So if the LOD is less than, I guess, and this one, we want to destroy so you should always yeah, so you should destroy the sphere. So you have a range of spheres, then it won't necessarily be in a certain order of any kind. So randomized jitter to hide the grid. Take a look at that. Sounds interesting. That's why you're having loads of fun with this now, isn't it? Ah. Nice. So you're jittering it. Right. I see. See, if we could do occlusion culling and it pays off doing this method, that'd be cool. Pretty dope. It's interesting. This is running in a web browser. It's got 180 spheres, 180,000 spheres. So yeah, nice. Yeah, you start getting a little bit of gaps. It ain't bad. Probably wouldn't matter at a low LOD anyway, because you'll be so far zoomed out that there won't actually be a gap. Awesome. So this is like a range of spheres, and in a shader, doing a for loop to find the right sphere to remove is not a good idea. You move the negative SDF to reduce the number of to reduce the edge is thinner. Ah. Oh, I see here, yeah. Gotcha. Yeah, you made it more of a, instead of a Death Star, it was, yeah, I see now. It used to be like more of a Death Star, because it's a smaller hole. Sure. Hmm. And more sensitive to, broken up by the noise. Oh, yeah, I see here, yeah. Oh, okay, as a test case. Nice. It could still work. Um, so we could just have a Holy array. I was thinking about, because these are going to be 0 to 8, sorry, 1 to 8 spheres. Well, no, 0 to 8 actually, spheres. So I was thinking about running a custom allocator where we just bucket them in powers of 2 up to 8, so it's only 4 buckets. But maybe we just allocate 8 all the time. And if we allocate 8 all the time, we can know which one it is and simply nullify it. Yeah, maybe we just nullify it instead. This way, we have to allocate more data though this way. So you could nullify the sphere, or the ellipsoid, whatever it'll be. Maybe a sphere in this case. It's 8 bytes. You could always zero the radius. It's going to be 8 bytes of sphere though. So you're always, like, this was a way to save memory, basically. It's that trade-off between memory and yeah, it's that trade-off between memory. But it does make the allocation strategy simpler. It's just fixed size ranges of 8 of them, right? And 8 times 4 is, yes, 32 bytes. So every leaf node is just going to have 32 bytes of these. It's not even a leaf. Even the upper LOD, the lower level LODs, level of details, possibly has some of these. If all of their children has a full cluster. So but it's only when we're constructing it, right? And when we're constructing it, it's probably fine. But then you're gonna have to swap remove across multiple threads possibly doing it at the same time, versus just nullifying a field out, which you will completely own that sphere because you're getting a coordinate per thread, right? Or are you? And also they're bit fields, so they're packed, so they can't use atomic operations. Well, they can, but you've got to be using... But you've got to pack them manually, and hopefully manually load the data up and pack it and store it back in type of thing. No, we're doing a lot at a time, so it should be safe. Yeah, I think we've got to go with a method. So if we're doing 8 spheres, we might as well just store the spheres in here, right? If we're just going to be allocating them, all 8 of them, we might as well just be chucking them in the node. Oh, no. Only the ones that need it. So you need the allocation. So you just need a sphere start index. So that sphere's range can actually just go. Make the allocator easier. Be faster. So, right, so you've got to know what you are in this cluster. So the problem is you can have multiple of your neighboring threads. So the beauty of this method is you're doing a 4x4x4, which means you've got 8 clusters in there. This is a cluster of clusters, right? It's 2 levels. It's 2 LODs, right? It's a yes, you've got yeah, because the cluster is 2x2x2. So this means that your neighboring clusters are going to be in the same group as you. Right, we've got a bit of a problem actually. We might have to do a 4x4x2 because then it'd be wave 32, and that way we know they all run in lockstep, right? Yeah, 4x4x2 because there's 32 threads in a wave 32, obviously. So this way you can get no. Problem is the cluster is a 2x2x2. So one cluster, or 2 clusters in this, are going to be spread across 2 different waves. And the whole idea is to have the same clusters. We'll do it in a local... Yeah, we'll do it in a group. Which means we might have to stick up some barriers and stuff, but I don't know if that's a good idea. We'll see as we write it out. Just got to think about it. So what's the next thing we need to suss? Okay, so sort of this sphere thing. So this means like, you know, so I'll put a bit of a comment up here. So we are painting over, we have painted over a leaf node that is a lower LOD, lower LOD that we are replacing with a higher level of detail later. So we want to remove the sphere. So we need to say node dot spheres start index, and we probably need a spheres buffer of cluster spheres. So we need a cluster spheres. Why is that data volume? Volume cluster node. And then cluster spheres. Volume sphere. Alright. So we need to say BC volume spheres. Now, we kind of don't want to go out of bounds here. It is kind of possible to go out of bounds if this thing hasn't. So this is a leaf node. We kind of want to say, probably for an if statement to say if this is not equal to and then the rest should be safe. Maybe. Okay. Sphere start index plus some form of so given my thread index, my dispatch, my coordinate, right? So it's the coordinate within this LOD. Given that, what is what am I inside this 2x2x2? So you just do a mod 2. So you need to work out your sort of child index, if you will. And that'll just be so your Z will be dispatch index.z times or mod 2 times 4. No, sorry, times 4 is it? It's times the it's a 3D coordinate unwrap. You need to do a slice, so it is maybe a 2x2. I think it's 4. And then you do a wait a minute, what does a 3D unwrap look like again? Where did I do a 3D unwrap in the code before? I did it in the I can't remember where that was. So this would be the width, wouldn't it? That'd just be 2. Alright, so let's double check that. Oh, there needs to be a mod. So I have to check to make sure I'm actually within the node itself as well. There should be a check to say basically terminate the thread here. So you wanted to say like if node, there's a left, is it like a left or something like that? Yeah, left bottom near. Like you want to know, hey, am I within this bounds? So given my if left if BC dispatch index.x is less than left, or YZ bottom near. So if we're less than any of those, then clearly we're at bounds. But also if we're greater than basically this plus 1. So you've got a 2x2 range that we're allowing into here at this LOD. So if that is the case, just return. So here we're just going to say, you know, return if this thread is out of bounds. We might not want to do this in all cases though. No, you might just need to guide it, to be honest. We'll think about this. We might remove it, actually. It's probably a bad idea. So on the lowest level of detail, you only get one thread that'll make it through here anyway. On the second one, it will go down the lowest. So yeah, the second lower level of detail, at the second lowest level of detail, you'll go through the first or the lowest level of detail node. That'll just be 0. It'll just be one cluster of 2x2x2. You would then have your dispatch index in sort of like scaled down to that LOD. Then you would pick the direction in which you need to go out of the 2x2x2 when you traverse down. And then you would go in that direction. Type of thing. Yeah, so I don't think you need this. But yeah, we'll need something like that, I think. We'll see. Okay, so we need to work out this sort of like... So it's not really this thing here. We need to know the dispatch index at this LOD. And at the next LOD. Yeah, this is probably dispatch index at the next LOD. Something. Yeah, but how would you know that? You're dispatching one thread for each cell in the grid at this LOD. Yes, this one is saying if the LOD is less than the target LOD. Excellent. So you need to move down. Okay, so given your... So we need to have the LOD that we're trying to do. So this is the LOD we're trying to fill in for. So right. So there's three. Okay, there's one called the edits target LOD. There's the construct LOD. We should call that construct LOD. That's good. Good name. So we need to get the LOD difference between and we need to create. So the LOD so the LOD will never be and BC construct LOD. So you'll never go past that LOD. So it's probably always okay to do that. So when we shift, we need to get our coordinates for this is our coordinate in next LOD. So that will be a bit shift left E32 BC dispatch index, right? And this would be LOD diff +1, right? So that's how you get towards this LOD, but we want the LOD above that, so it'd be +1. But what happens if you're processing the LOD? Wait, sorry, it's shift right, isn't it? I want to shrink it. Oh, it's -1 then. So you get lower and lower. But we only want to do this providing that it's less than the target LOD, so maybe it does go here. So if this has got this coordinate in the next LOD, that's what we use here instead. So we can do a mod 2 of that and see which child we're targeting. Then times that by 4 and that get you a slice. XY slice dot Y dot Z. Okay, so we can do child index dot radius equals 0, and we're just going to clear that guy out. Okay. So after you've painted over this one, you need to allocate a new... There's a bunch of different conditions we need to check when doing this. Be a bit complicated. And some of them might share the same branch. So we'll have to see how that ends up. So you've cleared out this sphere. Then you need to tunnel down, allocate a new child. So because you've got a sphere there shouldn't be... because you've got a sphere there shouldn't be a child node for that. Or it is a leaf as well. Wait, does it have to be a leaf? We might not need the bit set as well since we've got this system here, but I think we can. It doesn't have to be a leaf, because if you're painting over something, it just has to have a. Because the spheres could be there even if it is a. Yeah, I think you want to use this child bit set. You want to know your child index. So where am I going to go to? Has target child and one shift left child index. Wait, this goes here. That's what I wanted. Okay, so if it has the target child, like a node for that target child, then we don't care about getting rid of this, basically. So it doesn't have a target child. And we have this sort of inclusive lower set, which means when you paint down, it will remove any lower LODs. We should probably remove the sphere. And then you need to allocate a new node. Yeah, so in what cases I think what we should do is we should sort of kind of come up with all these different cases first, and then we can fill them in. Right, so let's go to the plan. Go to the notes. There we go, should be back. So we've got an inclusive lower thing to deal with. So when the inclusive lower is set to 1, we'll overwrite any below LODs. So it means we can replace it with a higher level of detail sphere. and basically get rid of those children. When it's 0, we want to preserve the lower LOD, and then we'll just stop. We'll stop there. We won't bother going any further down the tree. So really, right, if this thing is set or not set is a big decider on how much we go down this tree. So yeah, given that it is less than the target LOD, this is a big decider. Right, if this thing is set, so if this thing is set, this is how we carry on if we carry down the tree, right? If it's not set, we literally just so if we have something there, if we have a target child, so if we have a target child there, we need to remove it and then go down the tree. If we don't have a target child there, if the target child exists, remove it, go down the tree. Okay. And then this one's saying else. If we have a target child, then we need to wait, when do we need to return? The target child means you have a sphere there at that LOD. Is that right? I think it's if we don't have that child. Yeah, so if we don't have a child, then it means we are a leaf node. Well, not a leaf node, it means, yeah, so if we don't have a child, it means this is the lowest, we need to know if there's a sphere that's actually set there. That's the problem. Like, before we can actually return. Because if there isn't a sphere that's actually set here, then there's no, we might as well keep going so we can paint down basically. This is getting a bit branchy and confusing. Hey there, Tom Porus, how's it going? How you been? It's been a while. Yeah, so if you haven't got the inclusive load, it means you want to keep it there, but you only want to stop providing that there isn't any has higher LOD. That's a better way of saying it. Has higher LOD. So you kind of want to know if the sphere is set for this. So you need another Boolean. Has sphere. Do you need that has sphere? We'll probably do it here. So if it doesn't have a higher LOD, and this is the highest LOD, right, this is the highest LOD, and it has some spheres, and the sphere is not empty. And so the sphere is set, then we return. Okay, it starts to make sense. Yeah, I'm good, just saw you on, thought I'd stop by and say hi before bed. Sweet. Yeah, it's getting quite late here as well. Probably packing soon, but I want to just get a good structure out for it. But have you seen what we've been working on recently? I'll give you a quick tour. We basically got a little sphere renderer. We're trying to we've got multiple instances working very recently. We're basically filling a 3D volume with spheres. We're trying to work. We've basically planned out a very complicated clustering LOD system. We're just trying to figure out. We're just trying to get it basically working now. So I've just had a plan that we've been working on the past few. Got some glitches there, but yeah, past few days. But I've just got a plan together, so just execute on that plan now and try and get something up and running. So yeah, it's one of those rewrites basically. So this has been the demo, and now we're yeah, doing a bit of a rewrite. Yeah, so don't have higher LOD and a sphere doesn't exist. I guess I could just make a boolean here. Does sphere exist? You know, we could just do this. Right. Does sphere exist? Well, it's not really. Yes, it doesn't know how. And does sphere exist at child? If sphere exists at child, return. So we've painted over a leaf node at a lower LOD that we are replacing with a higher level LOD later. So, remove the sphere and then add a child. This one is saying, so this one is basically saying we have painted over a, is it a leaf node? Yeah, this one is a leaf node. So I've just kind of realized actually, something I didn't think about, is with this cluster tree, if a cluster doesn't have a cluster can have children of clusters for each one of the spheres. If that sphere has a child, yeah, that sphere has a child, then that sphere is determined by if that child's cluster is filled with spheres, right? I kind of talked about it in that way, but I kind of just realized, really just started grokking that here. Is that a problem? We'll see if that becomes a problem later. Should be alright. So we've painted over so a leaf node doesn't technically exist. Right, it's mainly like a leaf sphere. Right. So we should probably think about that terminology. We've painted over a leaf sphere. Yeah, you can get a leaf node, but it means that's all the spheres in there don't have any more leaves. Or any leaves of their own, any nodes of their own, right? Okay. So it doesn't have a higher LOD. Sphere exists at child. and and we are preserving this LOD, something like that. Preserving lower LODs. So stop here. Yeah. We've painted over a leaf sphere and we are preserving lower LODs, so stop here. So this one is saying we've painted over a leaf. So we don't, how do we know this is a leaf? It's this thing here, isn't it? So it's only... Yeah, so we painted over a leaf sphere. Do you care if it's got a sphere there? We don't, do we? So we get rid of the sphere if it exists. Guess child index is the way to go. So this is where we need to allocate a node, right? So to do allocate child node. So that you need. So if you've just got this inclusive lower, what does this part do? Like, so what happens if you don't go into these and return or create this one? So if you've got this inclusive lower, and you're adding, this will replace any spheres that you paint over in the lower LODs. Whereas, so if it does have a higher level of detail, you can simply just traverse to that, right? So this kind of branch in here probably can just be moved to the outside in that case. Right, okay, so I think that one's nailed. Let's think about the other case. So this sort of inclusive higher. This one is saying when you paint down, keep the higher level of details, and if you don't have it set, if you have it set, overwrite the higher level of details compared to your lower LOD. Wait, did I have the lower LOD in there? And if it's 0, then preserve the higher level of details. So the way the system works is this gets launched one at a time for every level of detail. So if you want to overwrite the higher level of details with a low level of detail, you simply, like, you're doing the higher level of detail after the low level's already done. So you simply don't place a sphere down if this thing is set, basically. Wait, is that right? will overwrite a higher. Yes, you basically destroy the tree. Um, yeah, you basically just return early, isn't it? Something like that. Hmm. Man, tree structures destroy my brain. So this one, you would overwrite the high level of detail. The high level of detail is done in a future invocation of the shader. So, um, so it's a low level of detail overwriting the higher level one. When you're traversing down the tree for the higher level invocation, you would discover this thing exists. Meaning you would stop here at this invocation. I just realized some of these might not be returns, they might be continues. They might be continue to the next edit. Whoops. So I don't really have a go-to for that. So you'll probably do something like probably just break instead. The only half listening, what happens to the spheres? Right, so the idea is we have like we have a grid. So yes, the idea is you basically paint spheres into a grid. Right, only when you sort of are building something. So you paint spheres into a grid. And you can paint them at different levels of details. So you can paint them at this small, right? You can also paint them at a lower level of detail and paint it like this. So if I were to have a flag to say I'm adding lower level, sorry, I'm adding the highest level of detail spheres down. So they should fill in this one here. But I've got a I've got something on which says a flag which basically says no, keep the lower level of detail. I just want to add the higher level of detail where the lower level of detail doesn't already exist. So in that case, this one won't break this guy up. Whereas if that flag is set or is not set, whatever, it will break this up into smaller spheres. It'll break it up into smaller spheres instead, right? So it's if you want to replace that or not, basically. That's the basic idea. So this higher one is the opposite way round, where you're painting a lower level of detail, but do you want to get rid of the high level of detail? Right, that's in the scene. So So if LOD is less than target LOD, Right, let's just do another one of these. So if this thing is set, you're going down the tree. Will overwrite any higher level of detail. So that will simply mean just don't do any work, right? So if this is set, and we've passed. So if we're at the LOD, yes, this is a question of when we're actually going to write the thing. So this is like if we're at the target LOD itself, right? So if we're at the target LOD, if inclusive higher, this is saying overwrite the higher LOD. Zero would preserve the higher LOD. So you just want to say if you want to find out whether or not you want to place down, and then you want to break at the end here because you've reached the max LOD. So, or you've reached the LOD where the edit is targeted for. So so this one is saying like, you know, place sphere. So if it's not inclusive higher, that preserves the higher level of detail. Anyway, so if it's inclusive higher, this will say over any high level of detail. That's only if so we're drawing at a lower level of detail, but there's already a node that's got something there that's higher. And we said to preserve the higher. Yeah, so now we just need to see if there's already a node there. So you want to know if it has any children, is that right? So if it has any child nodes, you got the child bit set for that. Right, so if that and has children. Okay, so you'll be like place sphere is equal to inclusive higher, which means get rid of them. If you won't have any higher level of details at this point, you won't be getting rid of them technically. So we place a sphere if overwrite any. Okay, so they wouldn't have been set in the first place. trying to think where this one makes any sense, because you're saying right, I simply won't place the higher LOD won't even exist yet. Like when you're going down and constructing the tree, like this shader invocation, your construct LOD would be lower. Like you've got to stop at the edit. Yes, this could technically be level of detail. Then you're probably like, you know, max LOD for this one would be probably the minimum between what we're constructing for and what the edit target LOD actually is, right? So if we're painting something that's higher than the construction, we don't bother going down all the way. Wait, can we just skip the whole thing? So we're constructing for a certain LOD and we go down the tree. We kind of want to clear the way and allocate some nodes, I guess. You want to at least allocate the nodes. You do need to go down the tree. If the edit that we're painting is... Yeah, you still need to do that. Okay, so this is the one that's confusing me a bit here. So, you know, this is where we're at the... Oh. Okay, so we're at the level of detail where we can actually place we're at the level of detail where the edit for the edit. So right, I think I get it now. This does make sense, this will work. So one will be overwrite any high level of details. So overwrite, okay. So you would have actually, your tree could possibly have children that need to get removed. So when you place a sphere, you need to do a check. If you do place a sphere, first of all, we need to work out this child index. So you're at a certain... just work out child index, and that one would just simply be BC dispatch index mod 2. Yeah, so you find your child index in a 2x2x2. Um, you find your child index in a 2 by 2 by 2. If it doesn't exist yet, then we need to actually allocate ourselves one of these, right? Allocate spheres array. Which we'll get into in a second. That should be quite easy because they should be all the same size, so it's quite an easy allocator to do. So after you've got that, you've got your sphere start index, and it should just be a case of going through the volume spheres plus the child index. Then you'll basically set up so you'll set up all of this. Yeah, I've got to be careful with the threading. Like, I've not really accounted for the No, I think I'm doing the multi-threading right, but I haven't double-checked it, so I need to definitely handle that at some point. Or definitely double-check over all that at some point. So BC volume spheres sphere index dot this. Then we've got to set it all up. So center position, whatever, I don't know what that'll be. We'll work that out in a bit. Unused is obviously not used, so no point setting that up. So you basically place your sphere down, and what else do you need to do? So you also need to say, well, if the child is also set, right? If the child has higher LOD, right? If we have a higher LOD, we need to actually remove like recursively destroy all the clusters that have happened. Yeah. So we need to recursively destroy all of those. This is very branchy. This is not going to be good GPU code. But anyway, maybe there's a way to make this branch less, but I don't know. We'll see. Dun, 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 dun. If it has a higher level of detail for this one, we need to recursively destroy the node and all of its children. Yeah. So it's an octree. It's possible to do it. But I was thinking when I was designing this, there might have been a way to avoid it from ever even existing. But you would have painted it down. You'd have painted down some stuff, and then in the future, you've come along and simply overwritten it with a low level of detail. So no, there is no way of getting rid of that until now. So you'd allocate it, get it all ready, just for it to go. Yeah. Okay. So we'll just write down what we want to do. So to do recursively destroy node.children indices child index. Starting with this one. Cool. So that's how we would do an add operation, right? So this add here as well needs to check it. So we haven't. The one thing we haven't done is we haven't checked if we're inside of the effectively the shape, right? So where's that going to fit into this? So given my coordinate, right? Okay, so that's the thing I was trying to do earlier, right? Given my coordinate that I'm currently in, and the shape that I've got here, am I inside like am I inside this shape? And if I am, then carry on. If I'm not, continue. Okay. Yeah. So we're probably best using sign distance fields for that. We've got an ellipse, and we've got, an ellipsoid and a cuboid. We do also have a rotation. I'm just going to do that now because it should be pretty easy. We've got a rotation. So we want to construct a quaternion from that. It should be quite easy. So this is our rotation that was stored, right? So we want to edit.rotation. We want to do a quaternion. And so it'd be like shift right 0. And 0x of f. Wait, is it like a scale? Boom. Let's scale the result by this. So 8, 16. We got 24 bits, you see. Okay, so then the W component was just set to 0. And then what we'll do is we'll reconstruct it. So rotation dot W will be equal to 1 take. Yes, you add all of these together. So just unpack that. There you go. So basically you got yourself a point. So there's your coordinate. You need to work out the coordinate at the LOD, at the LOD. So where did we do the coordinate LOD? At next LOD. We don't want that. We want the coordinate at this LOD. So from the construct LOD down to here, this current LOD. Wait, are we doing it? I think you just want to do the construct LOD. Okay, so you got your position. So what you need to do is you need to rotate that position into the local space of the object, and then we can simply do the test. So you want your new coordinate. So we could probably get it right. So you just want to do a center position equals quaternion rotate, or multiply vector quaternion with quaternion. So it would be rotation with the... Wait, we rotate in the center position? No. This is our... we'll just call it... coord in edit local space. So you're transforming this guy. Coord.x, coord.y, coord.z. So imagine, right, you've got yourself like an ellipsoid, which is kind of rotated a bit, right? So you want to rotate, you've got yourself a sample position right on the screen. What is it? Yeah, so you've got yourself you technically have the ellipsoid in, yeah, you technically have the ellipsoid like this. Man, I got to draw this right. Something like that. You technically have it like this in local space. So on the screen, when you sample this position here, you need to translate it back into the local space. So your position's kind of here instead on the in the 3D volume. And then you do a simple sign distance field check from inside that within the local space, right? That's the basic idea. So I need to get a SDF. So that's probably just the easiest way to check it, to be fair. Is there an ellipsoid? It should just be like a sphere, but you take away... Yeah, you just take away... Yeah, it should just be that, right? So where's the sphere one? So it should just be this, right? I don't know what coordinate space are we in? I don't know, let's just do 0.2, 0.5, 0.7, or 9, right? So that sphere over there, watch that change. Okay. Don't mind me. Oh, then you want to pick. Oh. Right, that didn't work. So you got your length. That's your relative position from within the... Right. Then you want to splat that out. Do the takeaway. And then you probably want to pick the minimum element of those. And that's your closest distance. So I think you want to do like vec. You'd be like t, something like that. Then you would say like return min t.x min t.y t.z No, because a min will do a. What does a min? Min does a union. Oh no, no, it should be fine. Hmm. Hmm. Ah, it's a signed distance, so min will do something crazy. All right. Maybe you just pick the min element out of them all. No, you wouldn't. That's dumb. Yeah. Oh, there's an ellipsoid right underneath. Yeah, this is a just an example on shaded toy done by IQ, right? There's an ellipsoid right here. I completely didn't see it. It's right there. Right, I wouldn't have guessed that. So this is approximated. Right, let's just grab one of them. I'm just getting a side distance field of an ellipsoid. I was trying to make one, but then I realized there was one right here. Yeah, I just want to check if the point is inside the ellipsoid, basically. So I just need one of these. So ellipsoid given a relative position in local space. We've got to get that right. So offset, I guess, or local space, sign norm position, like that. Right. Is it complicated? Right. So is there... Well, to be honest, I just need something that's a rough guess. Okay, I just need a rough guess, to be honest, because I'm just seeing... I just need to know if the ellipse... So I've got a grid, right? All I need is like, hey, I got an ellipse. Does it overlap these grid cells? Like, it's conservative, right? So it doesn't have to be precise. Yeah, graphics programming in general is pretty crappy like nowadays. They just made it really complicated, and then they like make it even more complicated by trying to do even more things for you, even though we're meant to be going more low level. Dun dun dun. But yeah, I think this could be alright. So you want to define the radius. The radii. The radiuses. But yeah, so it should be something like this. Ta-da. Here's one I did not program earlier. So len... Mac has always been... always will be trash. Yeah, I don't know. They had a moment in history where it was like, you know, this is pretty cool, but I don't know. They're really expensive and don't really give you good value for money, do they? Best is probably to express it as an as an equation and solve for min and max. That's where, Because obviously a bounding box is easy, but then like, you know, it's just that rounded part, you know. Mm. Yeah, I'm not sure how one would do that. If point is inside ellipse, I guess. Not sure if people. So someone's saying this looks pretty simple for my brain to understand. Right, this fair players Moscow. Appreciate it. Yeah, I think this one might do it though. So it's X take. So given a position, take H. This is what you'd have had to have done. Wait, what was K? Represent the origin of the ellipse. Yes, that's what we would have had to have done. Wait. The origin of the ellipse? Oh yeah, gotcha. Yeah, this is what we had to have done before we plugged it into here, basically. This is the result of taking those two away. So when you square them. Huh. See if I can write that out. So you take your point, you then take your center position of the ellipsoid and then radius. So apparently it's saying you get the difference. So it's just a subtract of going towards point from center pos. Then you square it, so then that makes it absolute, right? So you just square. Then you've got this radius squared. Right, radius x squared. Radius right. Right, then you sort of do and then it's basically just summing the elements together. Sorry, then dividing that and then summing the result of the elements. So it'd just be something like return some elements f32 times 3 divide diff squared by radius squared. Make sure that's less than 1. Wait, this kind of makes sense now. It still sounds so bloody obvious. Thinking about it. Like, you're getting... See if we can just draw this. So you're like ellipse. You got a point. You got your sample point you want to check if you're in bounds. You basically got a vector towards it, right? So that's what this diff is, and you square it. So by squaring it, you've basically got the absolute. It's an absolute. So it's always going in the same direction or whatever. Radius is kind of like a half width in a sense, right? It's like a half. It's from the middle to the edge. So you're squaring that as well. So basically, you've got these two vectors that point to like. So one points to like essentially the corner, maybe. Yeah, so it points to like the corner of it. This is not a very good ellipse. It points to like the corner of it or whatever. Then you're basically doing that divided by that. Right. So divided by it's a bit like the it's a bit like how you do a axis line bounding box. But then for the bounding box you'll check if they're all inside. Whereas this one says if you add them all up, they still have to be less than one. And if one of them is outside, then it'd be greater than one. That's really interesting. I didn't know that. That's pretty elegant. So then I guess we'll just do point inside A, B, B. I think I've already got this somewhere. But anyway, we'll just... So you have your half dims. Got your point. You do the difference. Okay, I guess it's squared. So the other one is squared, so that kind of plays it in an effect. You just get the difference. You get the absolute ABS. Then we're simply just doing all three less than equal diff is less than half dims. That'll do it. Oh wait, that's a good point. Right. You're going to test a point. You can create an affine transform with non-uniform scaling corresponding to the size of the ellipse. Transform the point. Test if the length of the vector is less than 1. That's pretty clever. You just create, right, transform the point and do a length operation. That's pretty clever. I think this one should be easier. Oh, sorry, should be quicker. It's got divide, but it's not got a square root. I don't know though, actually. There's still a lot of multipliers. Maybe it's about the same, to be honest, but that's pretty cool. I didn't know that. But yeah, this is testing a point. I kind of want to know if it's inside of a grid. So to do that, we could probably extend the size of the sphere of the. If we extend the size of the ellipse, So we're testing a point, right? So maybe the point could be in the middle. If you're touching anywhere, you extend it by half. You extend it by half the size of a grid unit. I think that'll do it. Yeah. Right, so we've got our things now. I think we just have to extend these guys by half the size of a cell, which is 0.5, and that should be fine. Okay. So each edit has its own shape. If we test it in so transform the coordinate local space. We then want to test, so we just basically want to say like or if is outside shape, we simply just want to continue to the next edit, basically. So now this is where we do the whole shape thing. Switch on edit shape. Data volume shape. So the ellipsoid. I wonder how slow this shade is going to be. Ooh. So we then just want to say basically, transform. We then want to take, I think we just want to say is outside. We'll default it to true, just in case. So this one will be equal to is point in ellipsoid. You pass in the coordinate. In edit local space. Then you pass in your center position of your shape. See, regardless, you need to have that sort of like, expanded half dims. And this would just be essentially add. We're adding a scalar, and that is half dims. We're adding 0.5 to the half dims. So we can test a single point. So the coordinate needs to also be offset by 0.5. So like add 0.5 so we can test for a single point to see if the shape overlaps a grid cell. Overlaps our grid cell. So center position, then we say expanded half dims, and then this one would just be for the axis line bounding box. Excellent. So if we're outside the shape, cool. So if we're outside the shape, then we'll simply continue and not do this edit. Okay. So it's coming together quite well. There's still a bunch of to-dos left to attend to, but we kind of got the basis in. It's definitely not, the logic is definitely not 100% there. So we've got the ability to, we're going over every single edit. Yeah, so we're trying to construct this cluster tree. We're going over every single edit. We're checking if the edit is actually, so each thread gets a cell, a grid cell at the target LOD. So this is launched 10 times for each LOD. We start at the lowest LOD, work our way up to the highest. One LOD is processed at a time with tons and tons of threads. Each thread gets a cell in the LOD of that volume. We're checking, if we're outside the shape, then we simply skip this edit, go to the next one. If we're inside the shape, we process the operations. We're in add. So we've just done the add today. We've still got to do the remove. Maybe there's some way to sort of share some code. Probably not, because, it would. So the best thing is that actually that wouldn't matter, because each thread should probably take, in a wave, will take the same branch. Will it? It might take the same branch. Yeah, we'll have to see when we optimize it. But if it takes the same branch, then it should be better at least. Yeah, it should be hopefully they're processing the same edit at the same time. We've got to make sure they do that. And we've got to make sure the compiler knows about it as well, because then it can optimize it. But anywho, so we basically have accounted for a lot of the complicated settings. Got some to-dos to do. I've got to double check this code to make sure it's all good, but I think we missed out on this one, which is the variable size simplification. Yeah. I forgot what that actually means, damn it. What does that mean? So you got a cluster filled with, oh yeah. You have a cluster that's filled. So we're basically going to say like lower LOD gen. So when you have a cluster that's filled up with spheres, you need to actually go back up the tree and generate a lower LOD version of that. That's the basic idea. That shouldn't be too hard at all. And then we've also got to, we've also got to check for, I'll write this down as well. Should be multi. But, but double check for when we are processing lower LOD levels, right? That's what I've got to double check, which I think is in this if statement here, when we're doing a lower LOD than the target LOD, something like that. Yeah, I've got to think about that. But right, I think that should do it for today. Let's find something to read. So I'll next be on Sunday at probably 6 p.m. GMT. Dun, 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 dun. Man, tree structures destroy my brain. I think the next stream should be a lot easier to understand, I reckon. Would have processed it a bit and my brain would understand, you know? Is there anyone doing any seed development or any custom engine-y stuff? Easier never. I know, right? Tree structures destroy my brain. OS dev, let's go. Run a floppy disk driver in 2023, because why not? Right. Have a good start to your weekend, everyone. I'll see you guys all on Sunday. And yeah, thank you, Kept Payne. You too, my friend. Have a good evening, guys. Have a good rest of your weekend, and I'll see you on a future one. Right. Catch you later.